Hello and welcome back. In section 4.3, we get to work with solving quadratic equations in one variable. So if you'll recall, we have seen this before when we were restricted to the integer domain. One thing to note in chapter 4, our domain is now the set of reals. So we no longer have to discard answers like 3/4 or -9/16 or pi over 7 or √3/2. Anything in the set of real numbers in chapter 4 we will get to keep. So a quick, just one little mini review problem on factoring. We'll do an x squared minus 8x is worth -12. So if you'll recall from our previous work on quadratic equations, our idea for factoring was to set one side to 0, factor, and set each factor to 0. So we'll add 12 to each side of this equation. So x squared minus 8x plus 12 is worth 0. So now our goal is to make a multiplication problem equal to 0. So we have a product of positive 12, a sum that's negative. So we have a -2 and a -6 will do both jobs. Leading coefficient of 1, we get to do the fast factoring on that. Remember, if this coefficient isn't 1, we do have to do the factoring by grouping instead. So either x minus 2 is our 0, and we union that up with the possibility that our x minus 6 was 0, and we go from there. So x could be 2, or x could be 6. Those are both definitely in a set of reals, so we get to keep them both. So the advantage of factoring fast and relatively simple. Again, relative. If it were easy, we wouldn't be going through it, but compared to other methods, it's not as challenging as some other methods can be. Major disadvantage does not always work. That is a huge disadvantage. If it only works sometimes, it's not necessarily all that useful. Now, one other thing that we need to learn about before we get into our other methods. We mentioned the domain is the set of reals. One little note here. Square root of -1 is not in the set of reals. That kicks us out into the imaginary portion of the complex number system. So basically it's just one more number set beyond what we're used to working with. And that holds for negative any number under a square root. So it is still possible for us to get kicked out of the domain even when we've expanded our domain to the real numbers. The number set that we've been working with so far has been the reals. We split between the irrationals and the rationals. Within the rationals, we have our integers. Within the integers, the whole numbers. Within the whole numbers, the natural numbers. Outside of that, we also have the complex. So numbers like square root of -7 would go out here. Square root of 3 would go in the irrationals. Rationals, 2/5. Integers, -4. Whole numbers, 0. Natural numbers, 1. So square root of a negative is outside of our domain. So our domain now is going to be the set of reals. It is possible to get something outside of that. So where do we use this? As far as quadratics, we can do the square root method. So if I have a problem like x squared minus 5 is equal to 0, if I wanted to factor that thing over the integers, I would be out of luck. There's no way I can find two numbers that will have a product of -5 and a sum of 0. Our b term is missing, hence the 0. We're not going to be able to find integers that will get that done, so we need a new method. So what we'll do is we'll get the perfect square alone. So x squared equals some number. Then we'll take the square root of both sides. When we introduce a square root to a problem that didn't have it, we need a plus and a minus. Write it in red, highlight it, do whatever you need to do to know that even on that first step, you need a plus or minus on the side with the constant. So x equals plus or minus the square root of 5. Those are both in the set of real since it was not the square root of negative. So we get to keep them both. We get to keep square root of 5. We get to keep opposite of square root of 5 in our solution set. Next one we'll look at, solving x squared plus 16 is equal to 0. Again, a product of positive 16 with a sum of 0, not possible using the factoring method. So we'll have to try this other method. So we'll subtract 16 on both sides. So x squared is equal to -16. Square root of x squared is plus or minus square root of -16. As soon as you see this square root under a negative, we'll jump to saying that this is the empty set. It's not saying that there aren't solutions that exist. It's saying there aren't solutions in the domain that we're working with. These are outside of the stated domain. Now, we don't always have necessarily something that looks exactly like that of the middle term always missing. Sometimes we have a quantity that's squared. We might have x minus 7 quantity squared is equal to 5. We have the perfect square equal to a constant. Once we're in that format, we take the square root of both sides, making sure to include the plus or minus on the side with the constant. Highlight it, circle it, arrows by it, whatever you need to do to remember that, yes, even on this first step, you need that plus or minus. There's two possible numbers that you can square to reach any perfect square. So for example, -2 squared is 4, 2 squared is also 4. So if we're going backwards, if we're looking at the square root of 4, there's two possibilities. We have to cover the plus or the minus. So x minus 7 is plus or minus square root of 5. So we'll add 7 to both sides. And that's typically done in front of the plus or minus. So x is 7 plus or minus square root of 5. We didn't do square root of a negative, so we get to keep both in our solution set. Let's see, we'll do one more with one extra step in it. We'll do x minus 2 quantity squared plus 6 is equal to 8. Take a moment and think, what is making this look different than the others that you've seen so far? This plus 6 should look different to you. So we'll fix that before we do anything else. So now that we have what we want perfect square equals constant. Then we introduce the square root on both sides, plus or minus on the side with the constant. So x minus 2 is plus or minus square root of 2, and we'll just add 2 to both sides. So x is 2 plus or minus square root of 2. That is in the set of reals, so we get to keep both of those. So 2 plus square root of 2 we'll keep. 2 minus square root of 2 we will also keep in our solution set. So you all try one. We'll try 2. So x plus 4 quantity squared is 7. X minus 6 quantity squared is negative 2. So go ahead and give those a spin, see if you can use the square root method on those. Okay, welcome back. So our first one, we do have perfect square equals constant. So we'll do the square root of both sides. Plus or minus on the side with the constant. So x plus 4 is plus or minus the square root of 7. And then we'll just subtract 4 on both sides. Again, usually in front of the plus or minus. So x is negative 4 plus or minus square root of 7. Those are both in the reals, so we'll keep them both. Our second problem was a little bit shorter. We still had perfect square equals constant. So we'll do square root of both sides, plus or minus on the side with the constant, but as soon as we see square root of a negative, we'll jump to saying that this is the empty set. There are no real numbers that will do this job. So our general sort of summary of square root method get to perfect square equals constant. So if you're not in that form, fix that. Square root both sides. Plus or minus on constant side. I'll put C for constant. Square root of a negative, go to the empty set. Else, solve it. Go to your solution set. So that's sort of our summary for the square root method. So the next method we look at is the quadratic formula. In that one, we have to start in this form. Ax squared plus bx plus c is equal to 0. So if you're not in that format, fix that first. And then we have x equals, yes, you need both sides. Don't forget to bring him along. X equals opposite of b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. And it's just a substitution from there. Simplify where you can. So for example, we'll do x squared minus 9x plus 20 is equal to 0 using quadratic formula. So here a is 1, b is negative 9, c is 20. So notice I'm keeping that sign with the b. So x is equal to opposite of negative 9, positive 9, plus or minus comes from the formula, square root of square a negative, you get a positive. Square a positive, you get a positive. You'll never get a negative out front here. So negative 9 times negative 9, 81. Minus 4 is from the formula. If you take the other version of intermediate algebra, or if you move into college algebra, you'll see where that minus 4 comes from. We don't go over that in this course where it comes from. So a is 1. C is, for this problem, 20. All divided by 2 times a, again, is 1. And then we simplify where we can. So we have 9 plus or minus the square root of 81 minus 80. And that's all over 2. So not just the second part, but the whole thing, including this 9. So x is 9 plus or minus square root of 1 all over 2. In this case, we got a nice, neat, pretty perfect square, so we can keep going. So 9 plus or minus square root of 1 is 1. So we have two possibilities, 9 plus 1 all over 2, or x is 9 minus 1 all over 2. So x is 10 halves, or x is 8 halves. So x is 5, or x is 4. Both of those are definitely in the set of reals, so we keep them both. All right, so next example, we'll look at x squared plus 6x plus 9 equals 0 using the quadratic formula. This is another one that we could have solved by factoring. We already had one side set to 0, so that was good. So x equals, don't forget to bring that along, that's an often forgotten part. And the quadratic formula, as many times as you have to look it up when you're doing your homework, write it down each time until you don't have to look back at it. That is a formula that you're expected to learn for this course. So opposite of 6 is negative 6, plus or minus, and square root all come from the formula. 6 squared is 36. Minus 4 is always there. Then we have times a in this case is 1. C in this case is 9, all over 2 times 1. So x is negative 6 plus or minus square root of 36 minus 36 all over 2. So x is negative 6 plus or minus square root of 0 all over 2. Square root of 0 is 0. So negative 6 plus or minus 0 all over 2, but negative 6 plus 0 is negative 6. Negative 6 minus 0 is the same thing. So in either case, we get negative 6 over 2. It is possible that we get only one solution from these guys. That is possible. Let's see, our next one, we'll look at a non-trivial leading coefficient. We'll try 5x squared plus 11x is worth 12. I'll put QF for quadratic formula. Here, notice we're not set to 0 yet. We have to fix that before we do anything else. So I'll subtract 12 on both sides. So 5x squared plus 11x minus 12 is worth 0. So A is 5, B is 11, C is negative 12. So x is equal to the opposite of positive 11, negative 11. Plus or minus from the formula, b squared, 121. Minus 4 is always there, times a this time is 5. C this time is negative 12. All divided by 2 times 5. Then we simplify where we can. Negative 11 plus or minus square root of 121. Watch your signs here. 2 negatives, we'll kick that over to a plus. So we have 20 by 12, 240. All over 10. So x is negative 11 plus or minus the square root of 361 all over 10. 361 is a nice, neat, pretty perfect square. 19 by 19 should give you a 361. So x is negative 11 plus or minus 19 all over 10. So one possibility, negative 11 plus 19 all over 10. Union that up with the other possibility, the minus 19. So x is then either a positive 8 over 10, which will simplify to 4/5, or x is a negative 30 over 10, which will simplify to a negative 3. 4/5 is in the set of reals, so now we get to keep our fractions. Negative 3, also get to keep that one. So 2 possibilities, both of those will work when substituted into the original. So the nice thing about this quadratic formula is this works every time. Factoring works only some of the time. The perfect squares, there's another method that you can learn to turn everything into a perfect square. We don't get into that in this course. Okay, so this next one, we do have this set to 0. If we didn't, we would have to fix that before doing anything else. So here a is 1, b is 3, c is 12. So x is the opposite of 3 plus or minus the square root of 9. Where did I come up with that 9? B squared. It's 4 times 1 times 12 all over 2 times 1. The square root should cover everything at the back there. The fraction bar should be under all of that. So x is negative 3 plus or minus square root of 9 minus 48 all over 2 by 1 is 2. So x is negative 3 plus or minus the square root of, and here's the problem, we come up with a negative, happens to be negative 39 all over 2. This one we would go to the empty set. So even if it's part of this more complex one, if I have a negative under the square root, that is outside of our domain. Okay, our next one, we'll do a 2x squared plus x is worth 2. So first off, we don't have it set to 0. Fix that before you do anything else. So 2x squared plus x minus 2 is equal to 0. Now we can identify our a, b, and c. b is the unwritten 1. C is not just 2, but negative 2. So x is the opposite of 1, plus or minus the square root of 1 squared is still 1, minus 4 from the formula, times a is 2, times c is negative 2, all over 2 times a. So x is negative 1 plus or minus square root of 1. Watch your sign work here. Again, 2 positives multiplied together will kick that over to a plus. And we have 8 by 2, 16, all over 4. So x is -1 plus or minus the square root of 17 all over 4. So while that is definitely not a pretty pair of numbers, it is a set of real numbers. That was all we had to have. So we get to keep both of them. We keep the -1 plus the square root of 17 all over 4. We get to keep the -1 minus square root of 17 all over 4. Definitely not something I would have come up with trying to factor this equation. So sometimes they look like this. We get something in here that is not a negative number, so we don't jump to empty set, but also not a perfect square. 17 is definitely not a perfect square, so we would stop there. So that should give you enough info to work on section, the exercises for section 4.3. And again, as many times as you need to write that formula down for the quadratic formula, write it down.